Okay, so we're going to look at number 11. So number 11, we have a car of mass 1,100 kilograms. And it's going to negotiate a circular turn. It's going a speed of 95 kilometers per hour. And that's 26.4 meters per second. And the radius of the curve is, I think, 345 meters. And they want to know mu. Well, we have an equation that tells us mu is equal to v squared over rg. So mu is equal to 26.4 meters per second squared over 345 meters times 9.8. So if I do that correctly and solve for my mu, when I did it, I got mu to be 0.206. Okay, I already worked number 12 for you. So we're going to go on to 13 now. In 13 you have a sine. And it has a wire running here. And I believe it has another wire running here. And from here to here is 0.25 meters. And then from here to here is 0.75 meters. So they want to know what is the tension in each of the wires that supports the sine. Well, the sine has a uniform weight of 325 newtons. So from here to here is a half a meter. And from here to here is a half a meter. Okay, so we'll call this T1, or T on the left and T on the right. Alright. So what I said was, well, I'm going to put my pivot where one of my tensions is, because that'll get rid of an unknown. So I said, well, if the pivot is here and I'm pulling up like that, then my sine is going to swing clockwise. So that tension is going to create a clockwise torque. And then this weight will make it fall. If this were to break and the pivot were here, the sine would rotate like that, which is counterclockwise. So that weight's going to create a counterclockwise torque. Well, since I have equilibrium, I know that those two torques have to be equal to each other. So I want to multiply the force times the distance, force times the distance. So let's look at that. Well, tension on the left is what I'm looking for. The distance from here to the pivot is 0.75 meters. Now, the weight is in the middle, so it's a 325 Newton force. And from here to here is 0.25 meters. So I'm going to solve for the tension on the left. Well, when I did that, I got the tension on the left to be 108.3 newtons. Now, because it's in equilibrium, these two upward forces have to balance the downward force called the weight. So if this is 108.3 newtons, then this one's going to be 325 minus 108.3. And when I did that, I got the tension on the right to be 216.7 newtons. Okay, we have 14 and 15 and we'll be done. Okay, so 14 says that we have a 0.00650 kilogram coin, so that's the mass. Rests on a turntable that rotates at a constant rate. It is 12.5 centimeters from the center of the thing, meaning the turntable. So there's my radius. And find the linear speed of the coin if the time for one revolution is 1.25 seconds. So the period is 1.25 seconds. So they want the linear speed, which is just b is equal to 2 pi r over t. 2 pi r is 0.125 meters. T is 1.25 meters, 1.25 seconds. So when I calculated my b, I got 0.628 meters per second. Okay, and then part B says, well, that's all great, but now what we want to know is the rate of rotation is gradually increased. The coefficient of static friction between the coin and the disc is 0.350. Determine the linear speed of the coin when it just begins to slip. Well, the centripetal force is provided by the friction, and so I can work from there and say, well, I know that mv squared over r is equal to mu mg, because that's my force normal. My masses will cancel. So I have mu is equal to v squared over rg. V was 0.628 meters per second. Don't forget to square it. The radius of this turntable was 0.125 meters. And gravity is 9.8. So mu, when I do that, is going to be you know what, I'm making a mistake here. I didn't think about what they said. They said that they knew mu and they wanted to know what the speed would be when it just began to slip. Okay, so v squared is going to be equal to mu rg. Mu is 0.35. R was 0.125. And G is 9.8. So that's b squared, but I want b, so I'm going to take the square root of that value, and I get 0.655 meters per second. Last one, yippee skippy, number 15. Okay, on number 15, we have, I think, an odd picture. We have this ball here. We know this angle here is 44 degrees. And so it says a young boy pushes on a stick. It is held horizontally and pushes a 15-kilogram ball to the side as shown. So evidently the ball was initially suspended here, and then the kid came and shoved it like that. And they want to know what force is that kid shoving with. Well, this is mg, so this would be ty, and it would equal mg, and this would be tx, and it would have to equal fx, because everything is in equilibrium. So we know that it is a 15-kilogram ball. So that tells us that that ball weighs 147 newtons. And we know that that means this is 147 newtons here. If I could write to where you could read it. Alright. And they want to know what is basically tx. So I'm going to say that the tangent of 44 degrees is equal to the side opposite, ty, over the adjacent, tx. So tx is really just ty divided by the tangent of 44. So ty is 147 newtons divided by the tangent of 44. And when I did that, I got not finding what my answer was. I apologize. So 147 divided by the tangent of 44, and I'm not sure what that was. But if you have a calculator, you can find it. All right, please study.